when you're developing in an environment where there is not much data, the application seems to be doing fine. But when it moves to production, we see more data being available in production, and that's where the problems start happening.
That is Anil Jacob, a principal engineer here at Salesforce on the Frontier Scale team. I'm Josh Burke, your host for the Salesforce Developer Podcast, and here on the podcast, you'll hear stories and insights from developers for developers. Today, we sit down and talk with Anil about his work on the Frontier Scale team, a team that works with customers that we were just describing there in his cold quote, large, complicated customers with either a lot of users, a lot of records, or both. And this team works with customers in order to increase their performance on various levels. So we're going to bring those tips and tricks to you, starting with the description of how LWC is a single-page application framework.
So Lightning itself is a framework that's used to create single-page applications. Now, single-page applications are those applications where a user can do most of the work while being on a page itself, on the same page itself. The user does not have to navigate to other pages to do the work that he's planning to do, right? So, like for example, say suppose we have an account executive. He is looking at a particular account, right? And the related details like opportunities or contacts, when it comes to Lightning, that information is also available on the same account page. So that means the account executive doesn't have to navigate to the opportunity page or the contact page in that case. And those are single page application, and that's what a single page application is. It's a huge productivity boost because we save a lot of time loading those other pages or navigating away to those pages.
So then why fundamentally is that an improvement over, say, traditional Visualforce if we're going like from controller to controller and page to page?
Right. So Visualforce applications that are made from the older technology like Visualforce, right? Visualforce framework, those are called multi-page applications. So multi-page applications, as I mentioned, like they are in contrast, so they actually users are meant to navigate to other pages to get the information that the user is looking for. Now, there is technically, if you go deeper, there is another fundamental difference. What happens is the multi-page applications are like Visualforce. The page is actually rendered in the server, right? And then it's pushed to the client, which is the browser in this case. Whereas single-page applications like Lightning, the page is actually rendered in the browser itself using JavaScript and HTML, right? And the page consists of small components, which actually are the ones that show the data and relevant information that the user is looking for. And these components retrieve the data on need from the backend system. So that way, the network bandwidth requirement is also low, and the page appears much more responsive compared to the earlier multi-page applications or Visualforce applications. That's a reason. One more reason is that the user experience is much better because of these underlying features.
Yeah, when I was doing enterprise web development, we always had that moment where the user is re-engaged with the interface, like it's not a white page, right? Like they know that the interface is trying to work for them. But let's quickly define slow. Like what is a time span that you've got in your head, which if the user's still kind of looking at that white void, that they're feeling like this page is taking too long to load?
Okay. So when users are using the pages on a regular basis, one point I would like to make is that even if the page is slower than, say, the difference between a page compared to an earlier version of the page is like, even there's 100 millisecond difference in the page load time, the users can actually make out. But to answer to your question, when I say page performance or page speed, right, I would say anything that is about 2 seconds, as long as there is some response from the page. As you mentioned, there is some sort of progressive information coming from the page. That means we see that the user sees that the page is loaded, the components are rendering, and there is some indication of something happening. That 2 seconds is pretty acceptable, right? Beyond that, I think users start getting impatient or start getting frustrated, right? So that's basically what I would define. So 2.5 seconds. But anything, if you ask me, being a performance and a scale engineer, I would see anything is better than 1 second, right?
Right.
Our goal is that. Our goal is 1 second and better.
Right. Because on the flip side, you're not trying to actually analyze slow, you're trying to analyze fast.
Yes.
And in fast, you're really thinking in terms of milliseconds, not seconds.
Exactly. Yeah. Anything that is in milliseconds, yes, that's what our goal is. But, it's not a realistic goal every time, right? So I'm trying to remember what our quote was back at my old job. It was something like 5 seconds is an eternity. Like if that's it's just you don't think about 1, 2, 3, 4, 5, but when you want to interact with something and get your job done, it's an incredibly long period of time. Yeah. It's that experience. Right? At the end of the day, it's the user who's using it day in, day out, right? We have to give them the best experience, and that is the numbers I quoted.
So let's tick off a couple of simple things. An application built on Lightning Web Components is effectively a series of components doing a series of parallel requests. How does the number of components being rendered on the page affect performance?
That is a very relevant fact, right? In the sense that the number of components on a page, as I mentioned, so pages are single page applications, Lightning applications are made up of components, right? So the number of components makes a huge difference in terms of the page load time itself. Because what's happening is the framework of the page is already loaded. It's the components that have to load. And when they say components that have to load, they have to get data from the backend and they have to render themselves, right? JavaScript has to execute, HTML has to render itself. So that time is basically what the user is looking at. And so when we have a large number of components, and I'll give you the exact number that will be beneficial, but when we have a large number of components, what happens is all these components have to send the request back to the backend systems, database and other systems, and get the data back. But we have to remember that the browser has only limited number of connections that it can open to backend systems. It has only 6 connections available. So that means 6 components can render in a decent amount of time, as long as the components are optimized, the backend systems, everything is optimized. And so if it's optimized, then what happens is the other components on the page will also appear as if they are loading fast, because the previous components are already loaded and the connections are now available for these other components to load, right? So the component performance makes a difference, and the number of components makes a difference, because if there are too many components, then components have to wait based on the theory that I just mentioned. Yeah. And also the speed of those components makes a difference, because then these components that are not yet loaded will keep spinning, and that can lead to user frustration.
Yeah. So first of all, it's fascinating to me that I've been doing web development for, let's just go with a really long time so that I don't age myself on my own podcast. And that's actually the first time I've heard that number 6. How is that baked into the browser? Is that like a standards that the browser's kind of accepted on, that like, hey, this is a reasonable amount of transactions that we're going to do with the server at one time?
So basically it's 6 to a given domain.
Okay.
So if it's multiple, so for example, let's take a different use case. So if, say, suppose you have a bunch of images that are coming from, some other domain, like maybe Netflix.com, and then you have another, say, component data that's coming from Salesforce. So then those 6 can load at the same time from the other domain, because it opens 6 connection to each domain, right? Whereas since we are getting data from the database, which is within the Salesforce domain, we have 6 connections available for them, right? So that is the limitation, the limit over there. Yeah.
Okay.
Because the browser has to do a lot of its own work, right, in terms of layouts and organizing the page, etc. So that's
got it.
Optimizing itself.
Got it. So if it's pulling stuff from a CDN, that's not getting in the way of like another Lightning Web Component. If I've got one really heavy, complex component, but I limit my other components down to say 4 to 7, then that page is going to be really relatively performant. And we'll talk about like component structure and stuff like that here in a second.
Correct.
But if I'm mindful of those groups of 6 and how much they can do at one time, I can kind of think about what my page needs to have on the screen at any given time and try to get that queue executed correctly. Does that sound about right?
That sounds right. Yes, absolutely. Yeah.
Nice. And so let's do talk about that a little bit. Like how do components like lists and tables compare to simpler ones, like maybe just a simple form or a button component?
When it comes to lists, so what happens is when we have longer lists of data, like for example, a list of opportunities on an account page, or a list of contacts, right? So what happens is the data, when it comes back from there are two levels to this. So one is the data has to be retrieved from the backend system. That could be through a SOQL query, or if it's a custom list. And then once the data comes to the JavaScript layer or the UI layer, it has to be rendered onto the browser, right? So it has to, the browser has to iterate through each of the list items, and it has to create the layouts and then show it on the browser. So for this reason, list can have a bigger impact because of this iteration. We see that lists have this longer list because of this iteration. It takes much more time, and we see that lists spend more time in the browser than in the backend. So we can pull a list of 2,000 elements very quickly from the backend through Apex or through SOQL query, whereas when that data is sent to the browser, that's where the delay is, and we say that it's a good amount of delay. So our recommendation in this particular case, when it comes to list, is always keep the list small. That means show a small list. This has got two benefits. One is the user sees a smaller set of data. It's much more easy to interact with that data. And also the rendering is much faster because the list is small. And then when the user wants to see more data, we can always do a pagination, either through a button or through a scroll based paginations, which is what the Salesforce components do. I compare this with other elements like a form, etc. So those don't have this kind of issues, but forms can have their own impact. I have seen a form wherein there were about 50 to 60 fields in the form, right? So those can have their own impact. But what happens is those elements don't have this kind of iterations. So they can be, if the number of fields are limited, etc., they can be rendered pretty fast. But
Gotcha.
I would take it one step further. One thing is that irrespective of whether it's form or a list or anything like that, or buttons, etc., it's always good to keep the number of elements on the page within a certain limit, because all these reside in the DOM of the page, right? So then the page, if the DOM has too many elements, it will take longer time to render the page.
I keep going back to like conversations with Chris Gray and conversations with, some of the, just like the holy grail of web development at some time became the fastest data table that you could produce, because it's complicated, it's tied to a lot of data, and everybody wants to use one. They're like so organizationally friendly that I'm trying to remember how Greg Lewis put it, but it was like it's the thing that you're always trying to get as most efficient as possible, and it's the thing that's going to be pushing you to be, to have as much going on as possible.
Yeah. So that's the reason lists are everywhere, right? Almost every page has a list, some list or other.
Right, exactly. So let's touch on one of the things that you talked about there a little bit, though. There's pagination, and then you can also use tabs. And how can structures like that help reduce what's going on with the DOM?
Okay. So let's take a look at let's go back to the page itself, right? So as we mentioned, we have the components on the page. Now, and we touched upon the fact that the number of components makes a difference, right? As the lower the number of components, the page would load fast. Now, we cannot tell our developers or our users or our customers to limit the number of components which would affect functionality, right? So what we would recommend in that case is have the components that you need on the page, but put them based on what the user requires as soon as the page loads, right? And then rest of the components, have them moved into tabs, because Salesforce, the page layout itself, the page itself provides options to create tabs. And then the components that are not immediately required for a user to start doing his or her work can be moved into tabs. Now, what happens with that is when the page loads, the components that are visible, or the active tab, and anything that may be outside the tab would load first, right? But the components that are within tabs do not load at all. So that means they don't take up space in the DOM, and the number of DOM elements remain low because only few components are active and visible when the page loads. So that way, the page loading is really fast. Now, I can give you an example. In this case, like for example, going back to the account executive, if he's looking at, say, an account page, and he immediately wants to look at, he or she immediately wants to look at only opportunities that are related. There's no point showing contacts, right? A list of contacts. The list of contacts can be put into a tab, and it is only visited when the account executive actually wants to look at contacts. But right away, as soon as the page loads, the opportunity list loads, and the opportunity list is available. But since it's only one component on the page loads really fast.
Gotcha. Well, in talking about like that account executive, another thing that you bring up in your blog post, which we'll link to in the show notes, of course, is thinking about it from the component level and asking yourself, like, does that persona need to have access to that UI element? So like, how careful should developers be about like, not just like a whole component, like a list or something like that, but within like their custom component, do I need to show this button? Do I need to show this field? Like, does the user actually need this? Or can I be a little bit more careful about conditionalizing it either based on a situation or a person?
Exactly. That is, yes. So the fact is that, as I mentioned, right? I mean, if the page has to be planned based on personas, the reason is typically what would happen is we would plan the page based on functionality. So what happens in that case is, hey, this is a sales functionality. What are the components that I need? Opportunities, contacts, maybe products, etc. All these are put onto the page. All these are visible at the same time. The page can take a long time because a lot of components load, right? But instead of that, Salesforce, the Lightning platform gives great feature, a really good feature where we can customize the page based on individual personas or profiles, right? So what we do is, in that case, is create pages that are relevant to a certain persona. Again, going back to the account executive or sales persona, we can show, okay, what does that user or what that belongs to that persona really want to see? Maybe only opportunities, right? He is only going to work on that. And maybe at the same time, if there's another persona, like maybe a business development executive, they want to see leads at that time. So each page can be tailored in such a way that the data that's shown in the components, the components that are relevant, can be tailored for the persona itself, and then assigned to that profile based on whatever they are planning to do with that page, right? So that way, components are reduced, and the page is much efficient.
Got it. Okay, cool. Well, moving into the world of Apex, what exactly is Platform Cache and how can it be used to speed things up?
Oh, that's my favorite topic, actually.
I like it.
So Platform Cache is a cache layer, is an in-memory cache that is accessible from the Apex from the platform, right? So like Apex has access to it. Now, the way we recommend users to or developers to use it is that they can move the data, which is based on like common queries that happen all the time. So common SOQL queries as part of their custom components. The result from those components, those queries, can be saved into Platform Cache. Now,
Mhm.
so it can be a list of opportunities, list of contacts, etc., and they can be kept there in the platform cache. Apex has access to it right away, and then when the component renders, it reaches out to Apex, and Apex retrieves the data from the cache. So the difference is the request from the component or from the user's browser doesn't have to go all the way back to the database,
Mhm.
right? So
Mhm.
then the cache serves it, and so it saves a lot of network hoops that have to be covered. And then because it's in memory,
Mhm.
there's no querying, etc. happening. The data is already there in memory. We always see that the retrieval from cache is always less than 10 milliseconds,
Mm.
or can be much more faster than that. So what happens? So this way, if you can imagine, the component and the page will load really fast because the data is almost instantaneously coming back from the
Right.
cache.
Right.
So that is where platform cache is really useful.
Talking numbers here, you have seen people have so faster data layers, a faster Lightning Web Component, and you've seen people take this strategy of converting things over to platform cache and have huge wins from a performance gain, right?
Correct. Yes. That is very true because we've seen some of our large customers use platform cache because they have requirements for, because as so many users are using it, having that data in cache. And
Mm-hmm.
and also one more thing is database is much more precious resource, right?
Mm-hmm.
It's more limited in terms of resources. And so saving that resource and having data served from cache makes it much faster. And so we also recommend, it's also a way of thinking that cache provides extra memory for the data that cannot fit in Apex, right? So it's extra memory, so we can go
Mm-hmm.
up to gigs of memory, right? So
Mm-hmm.
and that amount of data, that the data that resides there can be retrieved fast. So it's a win-win situation. We've
Mm-hmm.
seen all of our customers being really happy with platform cache, and every one of them want to use it for more and more use cases.
Nice.
So yes, so that is
Nice.
what we are seeing.
Nice.
Yeah, it's a
So
product that's growing.
yeah, well, and I kind of think it's interesting because going back to a lot of the things that the Frontier Scale sees when it comes to database performance and not understanding indexes or knowing where to some of the curves and gray areas of database design in general on the platform, but this kind of bypasses that, right? Like the goal is to not even you're not walking into those problems because you're not going to the database in the first place. You're just pulling things directly from the cache.
Totally, yes. I'll give you an example. I mean, we have a customer who was actually had a use case where it was the front end page was constantly polling the backend, right? In terms of like making just queries, and it
Mm-hmm.
would pull that data from the backend, and then whenever the data is available, it would send the data back to the UI, right? So
Right.
this polling was actually causing them to run out of capacity, right? Because it was like constantly hitting the
Boom,
database.
boom, boom. Yeah.
Yeah, exactly, right? And every request, even if the request is fast, it still takes a lot of resources, right? So when we put platform cache in between that and the database, and the request was served only from the cache,
Mm-hmm.
they could use the database for everything else, right? It was totally free, and they were able to use it for more. They were able to use more features, more users, without having to worry about any capacity issues.
Nice. Quickly, what's the difference between org and session cache, and how do we use them?
Now, org cache is both are part of platform cache, right? So you can partition, or you can divide the cache into partitions, and each partition can be allocated as an org cache or a session cache or both, depending upon how much space is given to both of them, right? So
got it.
The main difference between org cache and session cache, org cache, in the data in org cache is visible to any user or any process or within that org.
Got it.
So that means if there is another Apex application, or maybe a trigger, right, can access the org cache data based on if the keys known to that particular application. Whereas session cache is very private only to the user's session. So that means if there is a cache configured for a partition, when the user session starts, that session gets an attached space for session cache. And that session cache is only visible to the user's session. And during that, so for example, let's think about a shopping cart. So shopping cart is where, it's private to the user. The user would keep putting whatever items he or she would purchase into the cart, right? So this cart can go into the session cache because then it's private to the user. And when the user finishes processing, that cache can be removed, right? Or when the user logs off, the session cache is detached and removed.
Got it.
Whereas org cache can remain for a longer time and visible to all the users in the org.
Got it. All right. Anil, am I forgetting anything? Is there one other tip that you want to make sure people know when they're designing their Lightning Web Components?
Yeah, there are actually, yes. There are a few more items I would think about. Web components. One thing I can think about is we have this great feature called quick links, which can be configured on Lightning pages. It's a component, right? So quick link components, and it's a great productivity feature because it gives us a list of all the related items for a particular record. And when the record page is rendered, it shows up, what are the related lists, like list of opportunities or list of contacts, list of leads, list of campaigns, etc. for a given account. So these quick links, though they are really good as far as productivity is concerned because users can right away know what's related to that particular record, we would recommend it to be used little more carefully, especially when the org has a large number of users, right? When the scale or the usage is high, because these quick links have a feature where they show the number of records for each of these quick links. So that number is actually a count that happens against the database for each of this related records. So we would say the best option for that is if the usage is high, move these quick links into a tab. Use them definitely, but move them into a tab so they're not part of the page load.
Got it.
Right. So we have seen that if that is optimized that way, the page loads slightly faster, and it's actually beneficial for the end user. One more thing is there are a lot of things that we can do in Apex if the page uses custom components. In Apex, what happens is that when we have these components rendering back data from Apex, if the number of requests, if the component is going to get a lot of small items or small records, so a small amount of data from Apex and the backend, then it's going to make too many requests, right? So that eats up network bandwidth, right? So if imagine where users are sitting in remote areas or in COVID, a situation where we have users working from home, right? The network bandwidth can be pretty variable. In that case, it's always best to get a decent amount of data from the backend for one request from the component to the Apex, and then basically reduce the number of requests that go back and forth between Apex and the browser.
And that's our show. Now, there's more information from Anil on our blog. We will point to those articles in the show notes. Now, before we go, I did ask after Anil's favorite non-technical hobby, and be sure you stick around for this one because, well, I added in a little bit of twist towards the end.
I'm into painting and sketching a lot, right? So I do that all the time on the weekends. I go for classes, I go for open model sessions, and I enjoy it a lot.
Very nice. Okay, I'm going to ask one follow-up to that only because I was stalking on LinkedIn and I saw this, so I just have to ask: Do you still play table tennis?
Not in the last 1 year, 3 months, right? Because
right, it's a little harder.
But,
Yes.
it's really hard. Yes.
not a socially distant, friendly sport. Understood.
Correct, yes. So apart from that, I claim as being a very good table tennis player within all of Salesforce. But my colleagues, my friends don't agree with that. So that is that's an argument that always keeps going on. But I do play. Yes, it's my favorite actually.
All right. Well, I hope in post-pandemic times we can have a Salesforce table tennis championship.
Yeah.
And see who's right on that. I would love to see that.
Looking forward to that.
I want to thank Anil for the great conversation and information. And as always, I want to thank you for listening. When you want to learn more about me, you can catch me on Twitter at Josh Burke. I'm also on Twitch as Josh Burke. We do have a weekly Fortnite charity match that we do stream over there on Twitch. Now, if you want to learn more about the show, head on over to developer.salesforce.com/podcast, where you can hear old episodes, see the show notes, and have links to your favorite podcast service. Thanks again, everyone. I'll talk to you next week.